Let's get started. Get some bios. Aaron, you want to introduce yourself?
Yeah, certainly. My name's Aaron Colcord. I'm the Senior Director of Engineering for the Center of Excellence for Privacy. A little bit of background. I've spent a lot of my career actually building very actively data engineering patterns and practices. And now I get to work alongside such excellent customers such as Brad here at Corning, helping them implement and get real value out of our product at Privacy. So Brad, after you.
Thanks, Aaron. Brad Nicholas, Digital Platforms. Stood up Databricks 3 years ago at Corning, so I'm just going to walk you through our journey there. And basically, we're responsible for enabling digital transformation at scale, which is a bunch of babble to everybody. I mean, we're all into transformation, but we're talking about material financial impacts. I'll get into that. And just getting this to scale across 44 countries, 75 factories worldwide. Material science is kind of our bread and butter, right? I'll get into this a little bit more. But it's all about the financial impact. So why don't we, let's get started. So as I said, why is this about practical data governance? Because we're focused on a very specific strategic objective. We have an executive mandate to really make digital transformation happen. And that basically translates to financial impact. And we're all into the AI thing here, right? We're all into big data and data science and everything that it empowers. How do you really get to a material impact at a company the size of Corning? The answer is massive scale across all of our manufacturing operations, our finance teams, right, in terms of the way they handle cost controls, our logistics organizations in terms of inventory management, commercials teams in terms of forecasting. It's just basically the whole gamut. So it's a corporate-wide initiative, multi-year, and we need to hit the ball running, right? So scalable, valuable delivery with velocity. That means we need to prove something out that works. We go through a proof of concept phase. When we validate the value of that, we select projects based on their ability to scale up, right? So once you validate a unit of scale on a particular project is going to fan out properly and you can support it and you can count on the annuity stream that you're going to get out of that massive rollout, then you lock and load as fast as you possibly can and you move on to the next initiative. So that's basically what's driving all of it. Data governance is mandatory for all of this, but we're not about optimizing for data governance at the cost of velocity on our financial impact. We have to meet our schedules and our commits to the executive team. So, how do you pull that off? Well, we're focusing on the lakehouse. We focus on the lakehouse, we focus on landing the data, securing that, balancing, as you'll see, between control over data access, right, and protecting intellectual property and obviously privacy protection and compliance, dealing with all of that, while at the same time democratizing access to that and balancing it out so that we go mine insight, which is the fuel for all of the transformation we're trying to achieve. So kind of ground rules that we set early on, and I set early on, honestly, we're an open core shop. Digital platform, it's our initiative. So we will innovate at the pattern engineering level through pure open core and open source, and then we will scale with open core products. So we went with Databricks, we've gone with Privacy. Let's get to it. So what does this mean? What's the key to the value transformation to us? We need our domain experts who are not software engineers. Right? This is not a web company. This is a material science company, right? A massively successful one. And we need them to self-serve on insight. That is the key to making all of this work. So how do we do this globally? Well, we do need a professional software engineering team. And so we brought in SWEs, SREs, right? And they know how to make the web tech stack work, right? And we have to work around this core competency deficit, quote unquote. It's not a negative, it's just the nature of most companies that they're not software engineering focused. That's not what their mission is, right? So how do you make this all work? There's a reason Homer's on the slide. We've got to crack the code on scaling this stuff and making bulletproof, reliable, highly repeatable, and then we need to fade into the background. And it's a multi-year journey to pull that kind of stuff off, and it requires, an appropriate, skill set, right? Confluence of folks to really just hit every single stack here while we're pulling this off. So, what's the bottom line on all of this? If we do our job right and we have data governance in place, we have CI/CD, full automation, right? We have established patterns of practice that we can rapidly replicate, that we know that we can support globally. If we can really pull that off, here's what ends up happening. At Corning, people just are constantly mining insight. The domain experts have exactly the information they need to answer the questions they're asking. The velocity with which they're asking their questions goes dramatically up because they're spending a lot less time wrangling data, mining data, looking for data sources in various locations and what have you. Everything is prepared for them ahead of time. So that was really our focus for the last 3 years, right? Okay. So, classic high-level big data platform diagram here. So we're going to ingest from multiple data sources all over the company. They all have their specific IP constraints and PII and all sorts of other stuff. We have multiple divisions. The divisions they all have their own data stores, right? They need to protect their data, even from their own sister organizations. In some cases, we have co-opetition agreements or arrangements where we have legal obligations, and we can't have one part of one division even talking to another division. So all of that stuff has to be in place, because how are you going to mine for insight, first of all, if you don't have access to the data? But how are you going to make that happen securely? So that was really our core challenge. So the lakehouse was definitely key to us, right, in terms of just solving the landing problem. Just land your data. And we walked into a company where big data was not really something that was considered all that relevant or important. The nature of the company, the culture, everything else, the data was really siloed, heavily siloed all over the place. So getting people to land data, even that was a revelation. So landing the data in the lake, working the medallion pattern, right? Defining the specific patterns to actually maintain that data, keep the data flowing properly, right? And then enabling data science and all of the enrichment of that data to unlock the value and the insight that people are looking for. That's really what we're at. And as you can see there, our access governance solution is basically Privacy. Privacy wired in to Databricks with a focus on the lake. So this pyramid diagram here kind of hints at what we're saying. We're focused on the lake and not much else. What about these source systems? Are they locked down? Are they secure? Well, those transaction processing systems that form a lot of the data sources that we have, they're already locked down, right? You allow those systems to basically enforce their own data governance and don't try to boil the ocean. Now that worked for us because of our transformation objective I just talked about. It's not the total solution. You need to move to, with proper data governance, to an eventual single pane of glass, right? Protect every data source in an appropriate manner, and then enable access to that data, in a systematic way. So people need to be able to self-serve, select a particular data, get to go through a data stewardship, have that data approved, and then they can go to town and do what they need to do. But start somewhere aligned with your business priority, and then move on from there. So this all comes down to, as I said earlier, balancing your governance mandate with enabling borderless access to that data. Whoever needs that data, if they're testing a scalable value proposition, we need to make that happen, right? So we will give them access to the data they need. We need to figure out how to make that happen. We need to do it quickly, effectively. We need to be able to scale ourselves and not be a bottleneck. You can't do this without automation. It's just not practical in a company the size of Corning, a global organization, right? So policy as code is your friend. There's no other way to scale it out. You can't go policy crazy and then not have the tools to extend and automate, the whole process of governing that data, right? And Privacera has definitely enabled that for us, and Aaron will get into that a bit here shortly. But laser focus on that, heavy focus on roles, heavy focus on resource level, assignment and allocation, and then there's multiple tiers to all of that stuff. So just sorting through all of that and making that work in a way that's highly repeatable. So you have 2 or 3 people kind of managing the core strategy around that, and then they need to fan themselves out. We have a team in Asia. They need to know how to run it, right? And we need to just basically back each other up and on. So that's kind of the scenario that we're all in. So we're proactively leveraging data access control and discovery within Privacera. It's got a discovery module, it's got encryption modules. You can obfuscate, do whatever you need to do in that way. And then we rely on their policy cuddle tool heavily as kind of a plugin. So when we're doing policy management, it's all Terraformed. Terraform plan is your friend, right? We're constantly being very, very careful with the way we govern all this stuff as we scale it out. So that's kind of the key to the whole thing. And we'll serve borderless data when it's needed to drive value. If there's no value proposition, if there's nothing to that, we're not just going to open something up because someone's curious or whatever, right? They really need to have a legitimate reason to do that. So I suppose that's just kind of a high-level overview of what drove Corning to solve a data governance problem to enable our transformation journey. So with that, let me hand it over to Aaron, and he'll this is more.
No, thank you very much, Nick. That was an awesome overview. So when we start thinking about this, when we start beginning to implement, how do we balance democratization and these concerns? We have kind of this. We have this dichotomy we have to begin to start to break down. So on your left, you can see what is the dictated or the centralized approach. And I'm sure we're mostly used to that approach, right? Coming from warehouses being the predominant way for us to manage. Most of that data needed to go through a centralized team in order to be processed and put together. Now, you can see that puts a lot of power into that light blue dot there, and it makes it really big. But the teams, the people who actually own the data, the people who are enabled, they're extremely small. They don't really have a lot of power. But then if you go all the way to the right, you have the opposite problem. You have the cowboy problem, right? There's very little ability for you to enforce governance. A lot of people have access to the data. You can't do those practical use cases that Corning has around making sure that the right people have the right access to the data. So we need to find a way. How do we get to the middle layer? Now, I think, how many people does Corning have that we have to manage?
There's several hundred users on the system today, yeah.
Okay, so, and if I remember, the company's quite large. So we want to try to figure out, how do we get to a delegated approach where we're able to get the governance inside the approach and also allow users to get in there, start building value, putting the priorities of the company there first. So we're going to talk about how we get there. So what are the most common pitfalls around data governance? I have 5 on here. I'm going to talk about 2. 2 should really connect with you. Usually, we don't connect the value of the data governance program to the business outcomes. So it becomes extremely difficult for us to actually attach a dollar value of why we should do it or why we shouldn't do it. The other part that usually occurs, that usually begins to lead to failure, is inconsistent approach to data across projects. In other words, changing different approaches. Now we're going to be building up to a demo here around policy cuddle, which is going to attempt to solve both of those. We roll this up into this concept that we call minimal viable data governance. And when I say the paradox is real, it's kind of like, when we think about our data governance program, it should be very empowering. I like to think of it, it's part of your data management program and in alignment with your data management program. You're trying to achieve great things with data. So we're going to start with a concept called a data contract, where that basically spells out the legal obligations, what you're supposed to do, how you're actually supposed to do that governance. And very much like this wheel, you iterate, right? as you go through, you can build upon that definition, and you can measure, and you can increase and adapt your approach. This also allows us then to begin to create data products, for lack of a better word. And we begin to crystallize the value of why we do this project. Because without quantified value, as I said, it's really hard to justify. It's really hard to actually begin to connect what the business outcome to actually doing the project is. And if you remember on the last slide where I showed Decentralized, it should be very familiar almost all the time. If you go to centralized, there's always going to be a business group out there that says, we need to go faster, let's just ignore the centralized group, right? And they're going to build their own program. So creating a process by which you can come under even those rogue business groups, bring them in, and then bring that information back. That's their goal, to get to the delegated approach, that center part. So this is our approach. So this is the Pravicera slide. To show you our approach on this. Unified data access governance. So along the top, you begin to think in terms of how has the business organized their data, how we put it together. There's a lot of deeper meaning into this because we can have tagging, we can have discovery, but that's how we get to the tagging is through using a capability such as discovery. Look at the data, examine it, see what it is actually in reality from taking a look at it. Match the patterns. This is Social Security information. This is an email address. Being actually able to look at that and then actually being able to report that up. Access policy that can spread across any system and keep it consistent. That's a pretty critical one, because if we're to say the research on the top or even the compliance group on top, are we really concerned about the technology under the hood? Or are we concerned about the data itself and like how we're actually controlling and managing it and keeping control of it? So many of us use other tools to enhance our experience. AWS, Azure, Google, and other tools. So how do we actually extend out access policy and keep it consistent even there? It's very important because somewhere there's usually some leak in the system where someone can get in and take a look. Encryption and security, very important. We're going to actually have a good example that digs into how we can actually solve encryption and security and keep that a very relevant thing. But how many times have we built like some sort of encryption algorithm in order to keep a person from actually being able to visit and see the actual data? Now, more importantly, how do we scale that and make that so that applies to any type of sensitive information that we're seeing? The last one is auditing and having workflows. In other words, what is the single pane of glass? How are we seeing what actually happened and making sure that we can actually report in the past, see what people were doing, and even catch it as it's occurring. So I'd like to introduce the concept of Policyops. Brad called it policy cuddle. That's actually the name for it, and we'll actually demonstrate it. So Policyops is the ability for us to take all those aspects, the encryption, the security, the access control policy, the roles, who actually gets access to it, and begin to store that into version control, into a GitLab project, integrate that tightly with your development project. So when we said inconsistent approach to data projects, now we're bringing that together. You can bury that policy as code into the project that you're developing, into the data product, have that together and deploy that together and adapt that and have it trackable. It's based on YAML, and so that you can easily understand it. That's pretty much the standard for how we build these configuration files. And it's a very easy command line execution, which naturally you can integrate inside the GitLab runner for really good results. We're able to take policy code, so the concept of the data contract, test data sets, all these resources, we're able to bring the entire lifecycle. So the lifecycle should look very familiar where it starts as a developer, becomes source code, we store it to the repository, we build it, we check it, we deploy it, and then we see and then connecting back to that chart on minimal viable data governance, you're able to monitor, see what the good results are, and then repeat the cycle, keeping it extremely automated and adapting and tied to exactly what you're trying to achieve through building your data value. So let's talk about a demo scenario. I want to set up the demo here. So this is one of our enterprise stakeholders has a concern. So I have a very recent article, about 1 week old, I think. All right. So let's just talk about this scenario. There is a former AWS engineer who had misconfigured several of the accounts on AWS. And that led to Capital One losing $270 million. Now, this person naturally was eventually caught, eventually punished. And through those tools that they had, they were able to figure out what was going on. Well, now we have let's set up our scenario. The CSO, on his morning coffee break, is reading about this article, and all of a sudden he now has concerns. How do we actually manage, control, and keep control of our data? Now, I'm going to explore the security scenario because it's much easier for us to understand and visualize with the Policyops. So in this case, the CSO starts asking the real relevant questions. Okay, so if you misconfigured the AWS account, could they see the sensitive information? The answer comes back, yes, it's definitely happened. Could it be when we tell AWS to encrypt? Could we see it? Well, yes, because it's a misconfigured account. They've been able to make themselves an authorized user. So now it's going to decrypt for them as part of the process. Nothing wrong with the security layer underneath it. It was the misconfiguration that occurred on purpose. Now he starts digging into all these other services, Databricks, Redshift, and starts wondering, what about when we encrypt inside there? Can we do it? Again, the answer is going to come back yes. How are we going to prevent this? So he comes up with a new standard of how we're going to solve this problem. I want to make sure that the sensitive information is secure. It's encrypted even at rest and encrypted in such a way that these systems can't mishandle it. And I want to make sure that only the authorized users can actually see it. Okay, sounds like a really tough scenario. Normally that would be a pretty tough scenario, but we're going to show how to tackle it. Okay, so let's build some solution ingredients. Okay, and these are concepts inside Primavera. We will build an encryption scheme, which is going to define how we're going to encrypt the data, and what users can decrypt and what users can decrypt the data. Then, to make it a little bit more fun, we're going to create a presentation scheme. And a presentation scheme basically says that, let's use Brad and myself. Brad is from Corning. He's authorized to see the data. So when he sees it, the data, even though it's coming back encrypted at rest, it was decrypted for him. What about me? I'm not working for Corning. Let's come back and use something like a source preserving algorithm to make it look like it's about the same sort, like how the format is being preserved, but it's not the actual data. Okay. Now, we also, for good measure, will want to store our keys externally from the system so they're not contained within the AWS account, stored within Redshift, stored within Databricks. We want to make sure that it's separate. Just gets to security standards. And we're going to want to make sure our encryption can occur automatically in a workflow. Okay, sounds pretty tough. I think it's pretty tough, but okay. So let's get to a demo. All right, we'll just pull this up. So let's look at our data. So we've loaded some data onto our system, and we're going to take a look at it. Okay, looks like we have a lot of sensitive information here, including an email address and social security number. Could be something that someone could go and grab this information from. So we're going to focus on this email address for the purposes of this demo. So we can see it, and let's go and create it on a database as well. So that way, later on when we come back on this demo, we can show that it's encrypted at rest, but that presentation scheme's now assisting us in being able to read who the user is. So this is the policy cuddle tool. We built it on GitHub, and it's based on Python. And inside of it, we've built not only the process, but we've also put a lot of the instructions. We put some samples inside there that allow you to begin to build and integrate this, and more importantly, be able to not only run it through command line, but also hook it into your GitLab runner. So let's jump in and let's get some more details here on what we're going to look at. Okay, here's our documentation about how to do the CLI. And we have multiple functions inside there, such as the ability to just do a test dry run to see exactly what's going to occur before you actually do it, as well as apply. So we're first going to, we built the GitLab, and we're going to go kick off, create a policy, and then apply the encryption scheme. So we first have to create the policy, and then we're going to then say, let's go apply the actual encryption scheme to the data to make that happen. And now, while it goes and does its work, let's go look actually at the actual YAML file that we actually created to help define this. You'll notice how we're highlighting FPE, that's format preserving encryption. Now, under the hood, that's going to use Bouncy Castle, which is a proven algorithm that's been around for a long time to encrypt that data, but it's going to encrypt in a format preserving algorithm. Now, returning back to our GitLab, we're just going to wait till it finishes running. And you'll see that it's using the last name that we actually sent through the GitLab runner. And once it finishes running, great. So now we have all that contents, right? All those contents of what actually was executing was stored within GitLab as part of the process. So policy cuddle as part of its process is going to give you the information about what it did and how it affected. So now you have a good link of actually being able to go back and being able to repeat as part of that project, being able to connect your business outcomes to your project and making it an integral part of your actual deployment process in building data products. We can see exactly what it's done. We can go back, find out what it's going to do before we actually run it by using a dry run, and find out exactly what it did. Now, let's return, and we'll look at this data. When we look at this data, we can now see that that data has now switched and is now encrypted at rest. And you can look at the command. We're reading it directly off of the as raw as we can. And the data is now encrypted at rest. When we come down and we run the database portion, the data is still being decrypted because it understands the user on the presentation scheme is actually supposed to see it. So now we can actually now actualize the actual scenario where different departments need to be isolated, can't see the information. But more importantly, we're able to take what that CSO said, which would normally have been a very hard thing to do. So I've been on many projects where it's, hey, let's go change the algorithm to make it harder. And so we go back and we have to go figure out like, oh, where did we use 128 bits? Where did we use 64-bit? Then we find the one project which is using like 32 bits. And those usually turn into 1,000 hours, 10,000 hour projects. Here we are able to change it adaptly, extremely fast, and on the next sprint cycle. All right, so a little bit on some of the commands that you would use to run inside there, how we can do the typical, how we can clone the existing Ranger policies, how we can apply changes for a single policy, and how we can actually do that actual work. Naturally, all that is actually contained within the project itself. Now, my last final thought on this, When talking to Brad several times, we talked a lot about like how it is to be very open core, open source, what are the very critical elements. And a lot of us probably believe that being here at a Databricks conference with Apache Spark being a very open project and Databricks also being very open to it. We know all the advantages, the ability for us to adapt to our business, the ability for us to scale. And when we talk about scale, we're not just talking about being able to do faster velocity of computation. We're talking about extending those use cases and being flexible. We're talking about the interoperability and the extensibility that we get out of that. Now, us at Privacera, we're very committed to this concept of openness. And so Policy Cuddle, and even we're looking at even our policy sync server about how we're going to begin to open that up and be able to invite our customers like Corning and even our partners into the code so that we can build even further and more and make this available for more and more for everyone. Thank you very much. We do have some time, about 3 minutes for questions. Love to hear from anybody.
Questions?
Any question?
I'll make it, can we offer like free swag, Privacera, to people? Okay, here, for questions, you get something free. I don't know what it is,
The big
but
surprise.
it was Echoes earlier. I'm sorry?
I think we're just toking around. It's
Okay.
all good. Yeah, for the audience online. I do have a question about the compliance measures that you guys were talking about. So with the regulatory or compliance concerns that you were worried about, were those ISO, CFR? Can you tell me a little bit more about what kind of regulation you were worried about and that you're trying to protect?
Unfortunately, I can't comment on that. Sorry.
I'm not actually familiar with Apache Ranger. Does it apply also to GCP, ADLS, S3?
Apache, we do have integrations for Privacera for GCP, Azure, as well as AWS. I think we have over 90 different services that we offer that hopefully comprehensively cover the almost entire ecosystem.
Okay, cool. When you apply a new policy that says, I want this data to be encrypted at rest, so it has to go rewrite that data in the cloud storage, correct?
Yes.
What actually drives that rewriting?
So the Privacera, the components within Privacera actually manage and coordinate that and make that actually happen. And I don't know specifically which component it's actually is doing it, but that's essentially Privacera is built on top of Apache Ranger, so we enhance it. So we keep the open source project here and support and maintain it. So the policies, the tagging, all that information goes in here, so we keep it open source. And then the actual Privacera layer on top of it's the actual elements that's actually driving. Hey, go look through the S3. Go redo the encryption. I believe under the hood we might actually be using a little bit of Spark magic there to make that happen.
Yeah.
Cool, thanks.
So this question is for Corning. Can you share any stats on how big was your data and how long it took for the encryption? And when you do the decryption, is there a performance impact? I know security is out there, but more than that, the performance stats?
It's not something I want to comment on publicly, but I can
Okay.
talk to you privately about it.
All right. Okay.
Sorry.
Thank you.
So when you encrypt your data, right, can you do like table level, like the encryption, not only field level?
I'm sorry, say it again?
Can you do a table level, like the encryption?
You can do it at the table level as well, but most databases or platforms usually support the table level encryption, but we can certainly go through and hit every single column as well. But usually the pattern that we're looking for is use the discovery, find whether or not it's sensitive, and actually before you even do that, create a policy that says what is it that you deem sensitive, and then use that, and then use discovery to then look over the data, examine it, and say, hey, by the way, this is this. And then that policy then says, and I'm supposed to encrypt it like this. So you saw in the example there, we were actually applying something standard out of the box, which was system email. Like, oh, by the way, anytime you see an email, and then we actually attach like an encryption scheme to that policy, and then said, go discover it, and then also then do the encryption.
Yeah, thanks. I have one from online attendees. So the question is, what were your biggest challenges and how did you solve them? I don't have more.
I assume that's Brad's.
Oh my goodness.
Hopefully I will get swag for this, but.
Yeah. The biggest challenge was recruiting, honestly, making sure we had the appropriate staff in place, then getting buy-in from our intellectual asset protection teams across the company. And of course, we had our privacy officer, had to go through, we had to brief everybody on everything. So we partnered with information security and basically walked them through every single we jointly defined the policy enforcement that was required, and then we negotiated, right, just step by step. And we did this right at the beginning when we did the platform selection, even actually before we implemented Privacera. We then drilled down on fine-grained access control, additional control level with the Privacera tool. So I would say partnership, being explicit about what you're actually trying to accomplish, which goes back to Aaron's point about, aligning to business objective, right? Fortunately, we had, as I said at the beginning, executive sponsorship on what we were doing. So it was just a very collaborative effort to pull all that off.
Thank you very much, Aaron and Brad. It was really amazing. Great talk. Thank you.
Thanks,
If you
everyone.
have any more questions, come and approach us afterwards.